Okay. Is the screen visible to both of you?
Yes.
Yes.
So very basic. Quadratic Quadratics is basically when we're studying quadratic equations. Okay. And then what are quadratic equations? So equations basically have a variable, and the variable has a certain power. Okay. So there's something called a linear equation. Let's first see what a linear equation is. So a linear equation is a straight line on a graph, and it's something like, let's say, 2x minus 3. That's a linear equation. A general form of it would just be ax plus b, right?
Yeah. Okay.
And on a graph, this would just be a straight line. Whereas quadratic equations are when the power of x is maximum 2. So in a linear equation, the power of x over here is 1. So there won't be more than, the power x cannot be more than 1 in a linear equation. In a quadratic equation, the power of x can be 2 or it can be 1. So for example, 2x squared plus 3x minus 1, let's say. And then a general form for this is ax squared plus bx plus c. So as I mentioned, a linear equation will give you a straight line on a graph. On the other hand, a quadratic equation will give you a parabolic curve on a graph. I'll explain what a parabolic curve is as well. So let's say that we have these axes. Okay. So a parabolic curve is something like this. It could be like this. It could also be like this. It could be placed anywhere. Okay, but this is basically the shape. It's either a U shape or an inverted U shape, or some people call a smiley shape and a sad. So there are a
Okay.
few important parts of a quadratic curve. Okay, so we'll keep both of them side by side. Uh, so one can be like this, and then the other can be like this. I like to call the right one happy face curve. All right. Now, happy face curve has, so this point where, now if we look at the happy face curve, right now if I'm starting from the leftmost point and I'm going along the curve, so I'm going downwards, right? Till this point I'll keep going downwards, but after this point I'll start going upwards. So the point at which you change the direction of movement. So I'm initially going downwards, but after this point I'm going upwards. So that point at which I change the direction is called the turning point. Okay.
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 So a turning point for a happy face curve is at the bottom. So it is called the minimum point. On the other hand, if we talk about a sad face curve, so a sad face curve will have its turning point at the top, which is why it will be called a maximum point. Make sense?
Yeah.
Yes.
Now I'll just extend the sad face curve a bit. So let's say it's reaching the y-axis. There are two more things that are important for the quadratic curve. So one of those things is the point at which it cuts the x-axis. Cuts the x-axis are called its x-intercept. Okay. So a quadratic curve might have an x-intercept, it might have two x-intercepts, and it could also have no x-intercepts. Now, how does that work? So if the quadratic curve is, let's say, like this, then that means it will have no x-intercept because it's not cutting the x-axis. Okay. If it's like this, that its turning point is on the x-axis, it will have one x-intercept, which is the same as the turning point. All right. And then if it's like this, then it has two x-intercepts, which you can see over here, where it's cutting the x-axis twice. That's the x-intercept. And then similarly, there's a y-intercept, where the quadratic curve cuts the y-axis. So this is our y-intercept. All right. So similarly, we'll also have an x-intercepts and y-intercepts for the happy phase curve. Now, that these curves work is, so when I was drawing these, I just drew it from this point to this point. However, these curves will continue till infinity upwards. Okay. So obviously, I cannot draw that on my page, but they'll be continuing till infinity upwards, and they'll never end. All right. But when we're sketching in our exam, or when we're sketching on a paper, so obviously we can't sketch till infinity. So that's why we just sketch a part of it. But the most important parts of the quadratic curve are the turning point, the x-intercepts, and the y-intercept. All right. Does that make sense?
Yes.
Perfect. Now there are three forms in which we can have the equation of a quadratic curve, or the quadratic equation. So the first form is the standard form, which I also showed earlier, which is basically y equals to ax squared plus bx plus c. So this is showing us that the highest power of x is 2, and then the second highest is 1. And then there's a constant value over here. Now this constant value has a significance. So this c basically represents the y-intercept. So if you have the quadratic equation in this format, all right, now for example, let's say you get something, you're doing a question and they're asking you for the y-intercept, and then you have an equation written like this: y minus 4 equals 2x minus x squared. All right, so if you have to find the y-intercept, you should convert this form to this form. So I'll make y the subject, I'll shift everything else to the right, I'll make x squared the first term, then plus 2x. If I shift negative 4 to the right, it will become positive 4. So this is my quadratic equation in the standard form. And then, as I mentioned, this last term, which is a constant term, which has no x with it, that is equal to the y-intercept. So for this equation, the y-intercept will be 4. All right.
Okay.
Now, one more thing. So over here, the other important thing is the a over here. So if this a, the value of a is greater than 0, so if value of a is greater than 0, then the curve will be a happy phase curve. And if the value of a is less than 0, then the curve will be a sad phase curve. Now this seems difficult to remember, but it's very easy. If you think of it in this way, if the value of a is greater than 0, then that means that the value of a is positive, right?
Yeah.
So if the value of a is positive, then you're happy. So positive equals happy, so a happy phase curve.
Okay.
All right. And then on the other hand, there's a less than 0, which means that a is negative. So if a is negative, negative equals sad, so it's a sad phase curve.
Okay.
Okay, that was the standard form. Now let's move on to the next form. So the next form of the quadratic equation is the completed square form. So the completed square form is something like this. So there's y equals to a x minus h squared plus k, right? Now, why is the completed square form important? The completed square form is important because this helps us to get the turning point. Remember what the turning point was? Does anyone remember what the turning point was? Go ahead.
It's the point where the sign, where the point, for example, if it's negative, it's going to go towards the positive end.
Can you tell me if let's say we have a happy face curve, where
Yeah.
will the turning?
It's going to be at the minimum point, negative.
All right, it's the lowest point. Basically, it's the
Lowest.
minimum point. I think that's perfect. Sam, does that make sense to you?
Yeah.
Okay, perfect. So now these were the turning points for a happy face curve and a sad face curve, respectively. So the completed square form will help us get the turning point automatically. So if you're able to convert this equation into this form, so what this does is, in this form, the completed square form, h, comma k are the coordinates of the turning point. All right. So if you're able to understand how to convert standard form to completed square form, then finding the coordinates of the turning point becomes very easy. And today we'll focus on how to convert from a standard form to a completed square form. That will be the main topic for today. Once we're done with the forms of the quadratic equation. All right. And then similarly over here, this a has the same function as it had over here. So we can apply the same conditions over here as well, that if a is greater than 0, that is if a is positive, then you're happy, you have a happy face curve. If a is negative, that's sad face curve. Okay, now we'll just discuss the last form and then move to how to get the completed square form. So the last form is the root form. So this is something I think was covered in O-level math as well, where you did middle term breaking, right? Do you guys remember that?
Let's see. I think we have done, but with a different name. Might be.
I did, but I think I forgot.
Okay, that's fine. Okay, we'll do that in the future, inshallah. Today we'll focus on the completed square form. But basically, the form of the root form is basically something like this, that you have two factors. So you have y equals to a. There's, let's say, x minus, let's say, L times x minus m. All right. So that's basically the form. And then over here, m. So the significance of this is that this gives us the roots of the quadratic equation. We'll also discuss what roots are in the future. But so L and m are the roots. Again, we'll have to go into detail to understand what roots are, but that's what the root form is for, to get the roots. Okay, so let's move towards completed square form and how to get that, so that we cover one solid topic today. So I have kind of a few steps that you should follow when you're trying to convert a standard form to a completed square form. So what I'll do is I'll write the steps on the left, and then I'll also do an example side by side on the right. All right.
Okay.
So let's say we have y equals to 4x squared minus 24x plus 40. So we have to convert. So this is, which form is this of the quadratic equation?
Standard.
Standard form. And we have to convert it to the completed square form, which is something like this.
Yeah.
Now, the steps that I'm writing, the steps I'll be writing with respect to this standard form, the general one, ax squared plus bx plus c, so that you can apply that to any equation. Because obviously, when you get an equation, that doesn't have to be exactly same like this, but it will be similar to this. So I'll use these terms in the steps, but I'll use this equation to give you an example side by side.
Okay.
So the first step is take a common from first two terms. All right. So
Okay.
in the equation on the right, a is what is a equal to?
4.
4. So we'll take 4 common from the first two terms. If we take 4 common from x squared, we're left with x squared, and then from 24x, we're left with 6x.
6x.
And then we leave the last term as it is, right?
Yeah, okay.
Take the new coefficient, all right, I'm not writing the full thing, this is the coefficient of x, divide it by 2, square it, and add, subtract it in the bracket. So this is a very loaded step, but I'll explain that in the example in the bracket. So what's the new coefficient of x over here?
6x.
6. So the coefficient is 6, right? Coefficient is basically what's before the before x.
Mm-hmm.
So we need to take the new coefficient of x divided by 2. If we divide 6 by 2, what do we get?
3.
3.
And then we need to square it. So square it doesn't mean that we go to 9, we just keep it as 3 square. Okay. So when you square 3, think of it as 3 square. Now you have 3 square, you've reached this point. The next point is that you add subtract it in the bracket. So this was our, sorry. This was our bracket. All right. We have to add subtract 3 square inside the bracket.
Okay.
Okay. That's how you add subtract 3 square inside the bracket.
Okay.
Just a minute. So we've added, subtracted inside the bracket. Now the next step is, should I write the next step? So take out the last term from the bracket. So what's the last term of the bracket?
Minus 3 square.
Minus 3 square. So we'll remove that from the bracket. So if we have to remove something from the bracket, so we'll have to multiply that with what's outside the bracket, which is being multiplied to the bracket. So to remove negative 3 square, we'll have to multiply it with 4. Okay. So
Okay.
this will basically come. So negative 3 square is basically negative 9. If you multiply that with 4, that becomes negative 36. Am I correct?
Yeah.
Yes.
So negative 36 plus 40, that's what we have outside the bracket now. Now what you need to do is, now you need to remember an identity from O levels, which you've done, which is a minus b whole square equals to a square minus 2ab plus b square. Remember
square.
this?
Yeah.
Now what we can do, so again, these steps, you don't have to do all of these steps. These are just to understand them. When I'm doing it myself, I just skip steps, but just to explain this to you. So your thought process should be, you have x squared minus 6x over here. So this 6x can be written as 2 times x times
3.
3. Does this look similar to this?
Yeah.
Yes.
Right? So what can I replace this bracket with?
In what case?
So just a minute. So we're applying the identity now. So what I'm saying is, if we compare this expression with this bracket, so a is the same as x, right?
Yes.
B is the same as 3.
Yeah.
So what I want to do is, I want to convert this bracket to this form. So what would the form be? Do you understand what I'm trying to say or no?
I do, but
Okay, I'll try to explain this again. So what I'm saying is, I'm comparing this bracket with this expression. All right. And as you guys said, that A is the same as X in that expression, and then B is the same as 3. Right?
yes.
Okay.
So if A square minus 2AB plus B square is equals to A minus B whole square, can I say that X square minus 2X times 3 plus 3 square will be equal to X minus 3 whole square?
No, yes.
Does that make sense
Yeah.
to both of you?
Yeah. Yeah.
Okay.
That's the main step over here. So if you understand this step, that means you understood how we're doing completing the square method. All right. And then what we're left with at the end is, what will this be equal to?
Oh, +4.
Plus 4. So this is our completing square method, completing squared form. So remember, you look at the form. So that was y equals to a x minus h whole square plus k, and we've gotten a similar form, right?
Okay.
Okay.
Now, if I want to, if I ask you what the turning point will be, so can you tell me what the turning point would be? This is the general form. You can look from here.
Okay. Okay.
Okay, so what would that be over here?
It will be 4.
Okay, so the turning point is, so if you have this as the completed square form, the turning point is h comma k. So h is the term over here and k is the term over here.
That's -3 and 4.
Minus 3 or 3?
3 and 4.
3 and 4, right? Because this general term had negative over here. So if you
Yep.
get negative over here, you'll keep it positive for h. So the turning point is 3 comma 4. Will this be a maximum point or a minimum point?
Minimum.
Minimum point.
Points.
Minimum. Perfect. Because why would it be minimum?
Because it's positive.
Positive. And what does positive mean?
Happy face.
Happy face. So happy face has a minimum point. Perfect. Did this make sense to you guys?
Yeah.
Oh, yes.
Perfect. Let's do another example of this. So let's say we have y equals to. Do you guys want to take a picture of the steps?
I myself have written these. No.
Okay, perfect. Maya, did you get it?
Oh, yeah.
Okay. So our next equation is y equals to 2x squared plus 7x minus 12. Do you want to do this or do you want to try this yourself?
Let's see. I can try.
All right, Mahid, are you trying also?
I'll go get my notebook.
Sure. Sure.
Sir, how will we put the second step in it? Because if we divide 7x by 2 and it
So you can keep it as 7 upon 2.
okay, okay, we can keep it as 7.2.
Just keep it as 7 upon 2.
Okay. Sir, will it be like 7 upon 2 plus 7 upon 2 square minus 7 upon 2 square?
So it will be 7 upon 2x plus
Yeah.
7 upon 2 square minus 7 upon 2
Yeah,
square.
it will be like that. Yeah.
Oh, sorry. What would the common be?
Sorry, can you repeat?
What's the common?
Okay, so the first step basically.
Yeah.
So in the first step, you have to take the coefficient of x square, which is basically a common. So the coefficient of x square over here is
No. 7/2.
no. What's the coefficient of x square?
Oh, coefficient. Minus 12.
No. So coefficient is basically the the number that precedes the variable. Okay. So if you have, let's say, 2x, so the coefficient of x is 2. If you have, let's say,
Oh, okay.
3x cube, so the coefficient of x cube is 3.
3.
All right. So in
Yeah.
the first step, what you have to do is basically the first step over here was take a common from first two terms. So a was the coefficient of x square, right?
Yeah.
What's the coefficient of x square over here?
2.
2. So the first step will be that you take 2 common, and then you have x square, and then 7x would become 7 upon 2x. Okay?
Okay.
You get why it's 7 upon 2?
Oh, yeah. Cause
All right. Saim, in fact,
Yeah.
I think there was slight confusion. So you were saying that you're getting something like this, and then you have 7 upon 2 squared.
Yeah. And minus
Okay,
7
so
upon
no, yeah,
No?
that it won't be 7 upon 2 because so you've gotten this form, this step, right? Now
Yeah.
in the next step, what you had to do was you had to take the new coefficient of x. What's the new coefficient of x?
7 upon 2.
7 upon 2. Divide that by 2,
Oh,
right? So you take the new coefficient of x, divide that by 2. So what would it become?
7/2.
it's
So if you divide 7 over 2 by 2, what would that become?
7 upon divided 7 upon 2 by 2. Once more.
Yeah.
Yeah, it will be 1.75. 7 upon 4.
7 upon 4. Perfect. So what you'll do is now you divided the new coefficient by 2, then you
Mhm.
square it. So you have basically 7 upon 4 square, and then you add and subtract it. So what you do is you do plus 7 upon 4 square minus 7 upon 4
Yeah.
square.
बit
And then you have
confusing.
next square.
Then sir, why have we taken हमने ये क्यों लिया यहाँ पे 2 second step में?
This one?
No, 7 upon 2. We shouldn't have taken 2 here to divide it. No, ऊपर वाला. 7 upon
This?
2x. Yeah, this one. I've taken 2
So
here.
over here, we just took 2 common from the first two terms.
Okay.
So when we take this out, so for example, let's say you had equation like this. Let's say 4x minus 12. All right. You have to take
Okay.
2 common from the first two terms. So what would that be?
X squared plus
X square
2.
plus
2.
2. Why is that 2? Plus 2x.
4/2.
Yeah.
Because what you did was, sorry,
We divided 4 with 2.
exactly. So you divided 4 with 2, but
So if
because
we write this like
4 was
3.5,
sorry, can you repeat?
could we like write 7/2x like 3.5x?
You can. I mean, there's no issue with that. Uh, but when you try to apply the identity, so it might be a bit confusing over there.
Okay.
So, Saim, did you get why I did this?
Sir, I can understand समझ आ रही कि आपने कॉमन लिया 2 वहाँ पे कॉमन लिया and you but I don't
Yeah.
get it divide में 2 क्यों आया है? Why is there?
So,
Yeah.
okay. So if you look at this one that I've written over here, 2x squared plus 4x minus 12.
Yeah.
And then I'm going from this to the next step that's written. So when I'm taking 2 common, what I did was I first just got x squared because I removed this 2.
Yeah.
And to get this 2x, I divided this 4x by 2. Right?
Okay.
That's how I got this 2x.
Okay. So you are saying as we divide 7 upon 2, the answer will be multiplied by 2 and the answer will come 7. Okay. अब समझ आ
Exactly.
रहा है.
Yes,
Yeah, अब
perfect.
समझ आ रहा है. Okay.
Is the next step clear?
Yeah.
Oh no.
Okay, Matt, what issue are you having?
Uh, the step after the one. Um,
Did you get the step after this one, or you
no,
have
I'm
you
stuck.
stuck with
I'm
it?
stuck in the step after this one.
Okay. So the next step was that we need to take out the last term of the bracket. So we need to take this out of the bracket. All right.
Yeah.
So basically, what this 2 over here does is that this 2 is supposed to be multiplied with each term, right? Inside the
Yeah.
bracket.
Yeah.
If we're removing the last term, what you can do is you keep the first 3 terms as they are. Okay. And then for the last term, what you do is you just multiply 2 to it. So you can write it as, like, for example, negative 2 times 7 upon 4 square.
Negative 2
Okay.
times. Oh, okay.
Because 2 was supposed to be multiplied to all of the 4 terms. Now
Yeah.
this 2 is still being multiplied to all of these 3 terms, and then this 2 is being multiplied to the last term. And it's now out of the main bracket. And then you can simplify this easily, right?
Oh, yeah.
What will be the answer, sir?
So the answer is 2. So
Okay.
I'm telling you the turning point. Okay, I'll just
Yeah.
write the turning point. You can compare with that. Uh, this will be the turning point.
Minus 7 upon 4.
Maybe. Yeah. So the reason is that I think you'll probably have gotten something like x plus 7 upon 4 square, right?
Yeah, yeah.
So the general form that we had, that was x minus, if it's x minus h, then the turning point is h. Okay?
खुद से बदल दो.
No. So you can basically think of it in this way. Now you have this. So you can write this as x minus 7 upon 4.
Okay, okay, yeah.
Now you can
Now,
see you've got that term. So now
Mhm.
this part is h.
Okay.